Before we dive in, here's the deal. You're not just about to see a list of projects. You're about to step inside the machines, the ideas, and the sheer ambition shaping the future of the United States. From weapons that operate faster than human thought, to factories building the backbone of modern civilization, and even missions that could redefine where humanity lives next. Everything you came here to see is right here. And trust me, some of these will completely change how you think about what's possible. Welcome back. Today, we're counting down 10 of the most massive, complex, and ambitious megaprojects happening in the United States right now. These aren't just construction efforts or engineering challenges. They're statements about power, innovation, survival, and the future itself. For generations, Mars has been more than just a distant world. It has been a symbol of possibility, a second home, a backup plan for civilization. But turning that dream into reality has always run into one brutal, unavoidable truth. Getting there is incredibly hard. The physics alone make it feel almost impossible. Every kilogram sent to space demands enormous amounts of fuel, and that fuel itself adds weight, which requires even more fuel. It's a vicious cycle that has limited space travel for decades. So instead of trying to slightly improve rockets, engineers decided to rethink everything. The result is a machine unlike anything ever built before, a fully reusable spacecraft system designed not just to visit Mars, but to make regular trips possible. What makes it even more revolutionary isn't just its size or power, but how it's being built. The first missions won't carry humans. Instead, robotic systems will land on Mars, deploying infrastructure, generating energy, and producing fuel for return trips. For over 10,000 years, the woolly mammoth has existed only in fossils and imagination, a relic of the Ice Age gone forever, or so we thought. Now, a new kind of project is underway, one that blends biology, genetics, and cutting-edge technology in a way that feels almost unreal. The goal is simple in concept, but staggering in execution. Bring the mammoth back. It begins with DNA extracted from frozen remains, preserved in Arctic ice for millennia. Scientists have managed to reconstruct the genome, effectively creating a digital blueprint of the extinct species. But having a blueprint isn't enough. To turn it into reality, they need a living system. That system starts with the Asian elephant, the closest living relative. Using advanced gene editing technology, researchers are gradually modifying elephant DNA, inserting traits that define the mammoth: thick fur, fat layers, cold resistance. It's not cloning in the traditional sense, it's something entirely new, rebuilding a species piece by piece. While one project seeks to revive the past, another is focused entirely on the future of warfare. Hidden for decades in secrecy, a new aircraft has emerged, one designed to operate without being seen, a stealth bomber built to penetrate the most advanced defenses and deliver its payload anywhere on Earth. This machine represents a new era in military strategy. It doesn't rely on speed alone or brute force. Its greatest strength is invisibility. Every angle, every surface, every material is engineered to avoid detection. The manufacturing process is unlike traditional aircraft construction. Advanced composites are shaped with extreme precision, ensuring there are no imperfections that could reflect radar signals. Even the engines are buried deep within the structure, reducing heat signatures and noise. The result is a weapon that can travel across the globe, complete its mission, and return without ever being detected. Beyond Earth's atmosphere, another project is taking shape, one that could fundamentally change how humanity explores space. For decades, missions to the moon have been temporary. Astronauts visit, conduct experiments, and return. The limitation has always been the same. Every mission must carry everything it needs from Earth. The solution is to build a permanent station in deep space, a staging point that orbits the moon, allowing spacecraft to refuel, resupply, and prepare for longer journeys. The first components are already in development. A power module equipped with massive solar arrays and efficient propulsion systems will provide energy and movement. A habitation module will offer living space for astronauts. Once launched and assembled, this station will occupy a unique orbit that keeps it in constant communication with Earth, while providing access to key locations on the Moon's surface. Robotic systems will play a major role, assembling and maintaining the structure autonomously. Over time, additional modules will expand its capabilities, turning it into a hub for deep space exploration. Back on Earth, another long-standing challenge is finally being addressed. For decades, the United States has struggled to build true high-speed rail. While other countries developed efficient, fast train systems, attempts in America have repeatedly stalled. Now, a private effort aims to change that. The goal is to connect two major cities with a train capable of reaching speeds over 200 miles per hour, cutting travel time dramatically. Instead of developing new technology from scratch, the project relies on proven systems from abroad. Construction presents unique challenges. Acquiring land across hundreds of miles requires navigating legal and logistical obstacles. To minimize disruption, much of the track will be elevated on concrete structures built using a moving factory system. This approach allows for consistent, rapid construction, turning what would traditionally take decades into a more manageable timeline. But while transportation evolves, another industry is quietly shaping the foundation of modern life. Microchips power everything, from smartphones to military systems. And for years, most of the world's advanced chips have been produced in one region. To reduce reliance on external supply chains, a massive investment is being made to build advanced semiconductor manufacturing facilities within the United States. These facilities are among the most complex structures ever built. The environments inside must be nearly perfectly clean, free from even microscopic particles. The equipment used to manufacture chips operates at scales that are almost impossible to visualize. Using advanced lithography techniques, circuits are etched onto silicon wafers with features measured in nanometers. The level of precision required is extraordinary. These factories are more than just industrial sites. They represent a shift toward technological independence and security. Meanwhile, beneath one of the busiest regions in the country, a different kind of project is underway. A critical transportation tunnel, over a century old, is deteriorating. If it fails, the economic impact would be catastrophic. The solution is to build a new tunnel while keeping the old one operational. This requires constructing massive underground entry points and deploying enormous tunnel boring machines capable of carving through earth and rock beneath a major river. As the machines advance, they simultaneously install the tunnel lining, creating a durable, waterproof structure. Once complete, the new tunnel will allow for repairs of the old one, ensuring the stability of a vital transportation corridor. Far above, another project is focused on understanding the universe itself. A space telescope designed to look deeper into the cosmos than ever before has been deployed far from Earth. Its mirror, composed of multiple segments, unfolds in space, forming a massive surface capable of capturing faint infrared signals from distant galaxies. Protected by a layered sun shield, it operates at extremely low temperatures, allowing it to detect light that would otherwise be invisible. The images it produces are not just pictures, they are glimpses into the past, showing the universe as it existed billions of years ago. But while one system explores the cosmos, another is redefining combat in the skies. Artificial intelligence has reached a point where it can outperform human pilots in simulated combat. Now that capability is being tested in real aircraft. These systems learn through repetition, running millions of simulations to refine their strategies. Unlike humans, they don't rely on instinct. They calculate, adapt, and evolve. The goal isn't to replace pilots entirely, but to create a new kind of force, one that combines human decision-making with machine precision. And finally, one of the most ambitious defense systems ever conceived aims to solve a problem that has existed for decades. The threat of missile attacks has always been a concern. Intercepting them requires speed, accuracy, and coordination. This new system connects multiple sensors, satellites, and interceptors into a single network guided by artificial intelligence. It detects launches, predicts trajectories, and responds in real time, creating a defensive shield that operates faster than human reaction times. But as powerful as it is, it raises critical questions about control, responsibility, and the role of machines in decisions of life and death. 10 projects, 10 visions of the future, each one pushing the limits of what we can build, what we can understand, and what we can become. Because at its core, this is what defines progress, not just the ability to imagine something new, but the determination to bring it into reality. And the only question left is, what comes next?